Hello. Okay. Today, just a revision video on limiting reactants and excess reactant. At the end of this lesson, you should be able to determine in a chemical reaction the limiting reagent or reactant, the excess reactant, the percentage yield, percentage error, and the amount of the excess reactant that is left when the reaction is complete. This is just an example on how you can do that. This example here, number 4, among all the examples, is the question rates 50 grams of benzene, that is C6H6, was placed in a container of 160 grams of water or 160 grams of oxygen gas. After reaction, 30 grams of water was collected. 1. What is the percentage yield? 2. How much excess reactant was left after the reaction? Okay. This is an organic compound, benzene, reacting with oxygen. Obviously, this is a combustion reaction. The first thing in a chemical reaction like this, especially in stoichiometry, is you have to write a balanced equation. There was no balanced equation that was given. You should know that it is a complete, you should know that the oxygen will definitely be in excess. You should also know that the oxygen is always in excess, and that is why in excess oxygen, there is what we call complete combustion, giving carbon dioxide and water. How do we know that there is carbon dioxide and water? Because after the reaction, according to the equation, 30 grams of water was collected. So our combustion reaction should be benzene plus oxygen to give carbon dioxide and water. Let's see how we can write it. Thank you. You can write a reaction like this. Benzene plus oxygen to give carbon dioxide and water, and balance it. We will balance the carbon dioxide here using the carbon on benzene. There are 6 carbon in benzene. We balance the carbon here with a 6. We balance the carbon here with a 6. And now the carbon has been balanced. Now we need to balance, oxygen should always be the last thing to balance. We now to balance the hydrogen. Now on the left-hand side, there are 6 hydrogen atoms there. On the right-hand side, there are only 2 hydrogen atoms there. What must we do to make them up to 6? We put a 3 in front, and it will with 2 times 3 giving us 6 atoms of hydrogen here. So hydrogen have balanced hydrogen, carbon has balanced carbon. The last element there left is oxygen. Okay, now we have on carbon dioxide, we have 12 atoms of of oxygen. That's 2 times 6 is 12. With water, we have 3, making a total of, that's 3 plus 12, a total of 15 atoms of oxygen. Here, we have just 2. We have just 2. What number must we multiply by 2 to give us the 15 atoms of oxygen? 2 times 6 will give us only 12. 2 times 7 will give us only 14. So if we multiply 2 times 7.5, it will give us 15. So in that case, 7.5 can be got by, excuse me, 7.5 can be got by dividing 15 all over 2, usually a fraction. We balance oxygen using a fraction, 15 divided by 2. We now have a complete balanced equation. That's a mark for that. Now we bring down the data that was given to us. The masses that were given to us were 15 grams of benzene reacting with 160 grams of oxygen. Secondly, we need to calculate their MRO, their molar masses. The molar mass of benzene from the periodic table, carbon is 12, 12 times 6A, 12 times 6 plus hydrogen, which is 1 times 6, will give us a total of 78 grams per mole. Oxygen is 16 from the periodic table. Okay, 16 times 2 will give us 32 grams of 32 grams per mole as the molar mass of oxygen. Carbon dioxide, from the periodic table we have 12. 12 plus 16 times 2 will give us 44 grams per mole. Then for water, we have from the periodic table we have oxygen is 16. 16 plus 1 times 2 for hydrogen will give us a total of 18 grams per mole. The data is complete. Now we have been asked to calculate the percentage yield. The first thing to know to calculate the percentage yield, we only calculate the percentage yield. The yield, the word yield, means something that has been produced, a product, something that has been yielded from something, a product. The yield is the product that is God. And the product that is God can only be calculated. The percentage yield can only be calculated from the limiting reagent. The limiting reagent, we don't know. There are two reactions they have given. We don't know which one is the limiting reagent. So the first thing you have to do here is you have to determine your limiting reagent and the reagent that is in excess. There are 3 different methods we are going to use in determining the limiting reagent. The first method is we use the moles and the molar coefficients, using moles and molar coefficients. This is how it goes. The moles of benzene can be calculated as follows. The mass, the given mass, all over the molar mass. The given mass of benzene was 50 grams, divided by the molar mass is 0.6 moles. Now, we have to divide the moles by the molar coefficient. In their reaction, the molar coefficient here is 1. The molar coefficient here is 15 divided by 2. The coefficient here is 6, and the coefficient in water is 3. So divide by molar coefficient. The molar coefficient for benzene is 1. 0.64 divided by 1, it has a value of 0.64 for benzene. Now, let's calculate for oxygen. For oxygen, mass, given mass all over the molar mass, we have 160 grams that was given initially, divided by the molar mass, which is 32, we have 5 moles. Then we have to divide the 5 moles by the molar coefficient. And the molar coefficient, based on the chemical reaction, the molar coefficient for oxygen is 15 divided by 2, which is 7.5. 15 divided by 2. So we need to divide 5 moles by 15 divided by 2, which is 7.5. And the final value is 0.667. Based on this, we will be able to determine the amount, the value for oxygen. And the value for oxygen will be 0.667. Now, we want to compare their values. 0.64 for benzene and 0.67 for oxygen. Which one is higher? Of course, 0.64 for benzene is lower than 0.67 for benzene. Therefore, benzene is a limiting reagent. Meanwhile, oxygen with a higher value is the reagent in excess. Another method that we can use in determining which is the limiting and which is the limiting and which is the reactant in excess is method number 2. The method number 2 is comparing the yields from reactants. We want to compare the yields from the reactant. Let's see how it goes. The yields from the reactant. The same reaction from benzene and oxygen to give carbon dioxide and water. We want to compare the yield. We want to compare how much of oxygen will be produced by benzene and how much of, we want to compare how much of water will be produced by benzene and how much of water will be produced by oxygen. Now we want to compare how much benzene can give. If in a simple proportion, looking here is 1 mole to give 3 moles. If 1 mole of benzene gives 3 moles of water, from the equation. Therefore, the number of the moles of benzene that we calculated from above, that is, we calculated from above, was 0.64. That is dividing the given mass by the molar mass, was 0.64. 0.64 moles will give how much of water? It will give us 1.92 moles of water. Now you are given the moles of water. Now, in order to have the mass of water, use your triangle that has the mass, the molar mass, and the moles. To have given the moles, in order to have the molar mass, in order to have the mass, we multiply the moles by the molar mass. So the moles are 1.92 times 18. We will have 34.56 grams of water. That is being produced by benzene. So benzene will give us 34.56 grams of water. Look for oxygen. If we look at the reacting moles, we have 15 all over 2 moles of oxygen will give 3 moles of water. Therefore, the 5 moles of oxygen, that is the mass, which was 160 divided by 32, 5 moles of oxygen will give what? How many moles of water? We calculated this. It will be 5.2 divided by 7.5, and that will be 2 moles of water. Given the number of moles, how can we get the mass of water? We will multiply it by the molar mass to have 36 grams of water. Okay, comparing the yields of oxygen and the yield from oxygen and the yield from benzene. If we compare the yield from benzene and the yield from oxygen, benzene will produce a lesser amount of water than oxygen. In that case, benzene is limited. Meanwhile, oxygen is in excess because oxygen produces a higher amount of water than benzene. Another method we can use is by comparing reacting and the calculated masses of the reactants. In that case, we want to see how converting mass to mass, converting the reactant benzene to oxygen. Here we have mass to mass conversion has about 4 stages. The mass of benzene to the moles of benzene, the moles of benzene to the moles of oxygen, the moles of oxygen to the mass of oxygen. We do it as follows. 50 grams of benzene was given. We can now 50 divided by 78 will give us 0.64 moles of benzene. Then times the mole ratio, which is 15 all over 2, we will have the moles of oxygen. Then the moles of oxygen times its molar mass, which is 32. We will have 153 grams, 153.6 grams of oxygen. This is the amount of oxygen. We now compare from here. 50 grams of benzene. 50 grams of benzene requires 153.6 grams of 153.6 grams of oxygen for complete combustion. This is the calculation. 50 grams of C6H6 will need 153.6 grams of water for complete combustion. Remember, in the equation, or from the initially, 160 grams of oxygen was given. If this amount will only require this amount, but initially we were given 160 grams of oxygen. In that case, more of the oxygen will be left because only 153 will be used. So we now say C6H6, which is benzene, is limiting, while oxygen will be in excess. These are the different methods you can use in calculating or in determining the substance that is in excess and that which is limiting. Now, in calculating the percentage yield, the percentage yield is usually the actual yield all over theoretical yield. Another word for theoretical yield is the calculated yield times 100%. Now, from the equation, from the onset, we were told from the onset, as the question says. The question says from the onset, after reaction, 30 grams of water was collected. That was the experimental yield. The actual yield or the experimental yield, that was it. The actual yield or the experimental yield was 30 grams was collected. Now, percentage yield is the actual, or what we call the experimental, divided by the calculated, or what we call the theoretical, times 100. Now let's do our calculation. Okay. So we have got 30 grams to be the actual yield, or the actual yield or the experimental yield. In order to calculate our percentage yield, we will now say 30 gram of water divided by 34.5 grams of water that was produced by the limiting reagent times 100, which is 86.8 grams, 86.8%. Secondly, how can you get your percentage error? Your percentage error will only be subtracted or deducted from 100. That is 100 minus the percentage yield. 100 minus percentage yield will give you the percentage error. And when we do 100 minus 86.8, it will give us 13.2. This is how you can get your percentage error. The last section of it is excess reactant. Excess reactant. Excess reactant left after reaction. In this case, we have to use the reactant, the excess reactant. The excess reactant, initially, the amount of excess reactant was 160. Then, after the reaction, after the reaction, how much of the excess reactant was left after producing oxygen? Excess reactant, we say that is from here. We want to calculate excess reactant from here. Excess reactant, we are calculating excess reactant from here. Excess reactant is, we are making a mass to mass conversion. We are converting the mass of benzene to the moles of benzene, the moles of benzene to the moles of oxygen, and the moles of oxygen to the mass of oxygen. And if we do like that, initially know that we were given excess of oxygen was what? Was 160. In order to do this conversion here, this is how we converted it here. The mass, converting the masses, benzene to this. So we did a mass of benzene to moles of benzene to moles of oxygen to the mass of oxygen. We calculated this and we had 153.6 grams of oxygen that was being produced in the reaction. So now excess left is the total mass or the initial mass that was given minus the mass that reacted. And the mass that reacted is what? 153.6 grams of oxygen. In this equation, we can now calculate here. Mass to mass conversion, which I've just shown you above, gave us 153. Then the total mass that was given from the beginning is 160 grams. So the difference will be 6.4 grams of the excess that will be left after the reaction must have gone through or was completed. 6.4 grams of the oxygen was still left because we are calculating from the excess reactant. This is how you can calculate your excess reactant. This is how you can calculate the excess reactant. A recap: there are many ways you can calculate limiting reagent by using the moles, by using a limiting reagent by using moles and the water coefficient and the molar coefficient to have it. And method number 2, by comparing yields from the reactant, that you have to calculate the yield from the reactants. For example, calculating how much benzene can give, amount of water benzene can give, and how much amount of water oxygen can give, and you compare the value. The one with the higher value will be the one in excess, the one with lower value with the limiting reactant. Now you can still use, the third method is by comparing reacting and the calculated masses of the reactants. And when you do like that, using the mass to mass conversion, you will have the mass that has been reacted. You will also use the mass that have been reacted in calculating the percentage, in calculating the excess yield. Because since oxygen is the excess yield, you will use it to, you will deduct the mass from the total mass of oxygen and you have what will be excess left. And that is how you can do it. Percentage yield, you calculate it by by using the formula, percentage yield is equals to the actual yield, or what we call the experimental yield, divided by the theoretical yield, or what we call the calculated yield, times 100, and you will have your percentage yield. Percentage error is by deducting percentage error is by deducting the percentage yield from 100. You will get it, and the excess reactant left is only calculated from the excess. It will be total mass of the excess reactant minus the mass of excess reactant that reacted. You will have the excess reactant that was left after the reaction. By doing like this, by doing all these stoichiometric calculations, it is easy to have the quantities that are reacting. It is easy to determine the quantities that are limited. It is easy to determine the quantity that are in excess. And it is easy to determine the percentage, the percentage yield and the percentage error. Thank you very much for listening. Bye-bye.